Hey everyone, welcome back to the channel. Today, we're diving into a fascinating new idea in multi-agent systems, or MAS, especially for complex tasks like getting many agents to move around without crashing into each other. That's multi-agent pathfinding, or MAPF. Now, coordinating a lot of agents can be a real challenge. Traditionally, agents might coordinate by explicitly sending messages to each other, essentially saying, "I'm going here," or "watch out." But as you add more agents, this explicit communication can become a huge bottleneck and chew up a lot of computing power. This is where a new approach called SRMT, the Shared Recurrent Memory Transformer, comes in. SRMT is designed to tackle the challenge of coordinating agents without needing them to explicitly predict everyone else's behavior or constantly send messages. The core idea is this: instead of direct messages, SRMT uses a shared recurrent memory. Agents contribute information to this shared memory, pooling their individual observations or working memories. Then, they can access this collective memory through a mechanism called cross-attention. This allows agents to implicitly exchange information and coordinate their actions. Think of it like agents contributing notes to a shared whiteboard and reading notes left by others, rather than having a dedicated chat session with every single other agent. The big win here, and something we talked about before, is that this approach significantly reduces computational overhead compared to traditional message passing methods. Why? Because once that shared memory space is set up, agents can access it directly. There's less kernel involvement needed for data transfer compared to the constant system calls often required for message passing, which can be costly and time-consuming. This direct access leads to faster communication and is overall a more computationally efficient strategy, especially for sharing larger amounts of information implicitly. Beyond being more compute-friendly, SRMT shows other benefits. It enhances cooperation, helping agents avoid common problems like deadlocks by leveraging shared historical information. It also improves generalization to environments the agents haven't seen during training and scales well in complex settings. On benchmarks like Pojima, SRMT is competitive with other advanced methods. Now, it's not a magic bullet for every scenario. The sources indicate that in highly congested environments, like a tight warehouse map, SRMT's performance on throughput can sometimes be surpassed by methods that integrate heuristic planning. This suggests that combining SRMT's learning-based, implicit coordination with explicit planning techniques could be a way to handle the most challenging, congested situations. Also, extremely complex coordination might still be better handled by centralized methods. But for many multi-agent coordination problems, especially those where you want to reduce the computational burden of explicit communication, SRMT's shared memory approach offers a powerful and efficient alternative. It's a really interesting step forward in getting AI agents to work together effectively and efficiently. Hope this gives you a good overview of SRMT and the power of shared memory in multi-agent systems. Let me know what you think in the comments below.